molarity and molarity calculations to stoichiometry. It's going to be a relatively short lesson, I hope, because stoichiometry is something we should be familiar with at this point, and we're just going to be applying solutions on top of it. Another way of getting to or from moles in order to use stoichiometry. So as we talked about in the previous lesson, the molarity can be used as a conversion factor between volume and moles. And so we can either use the molarity, straight moles over 1 liter, or we can invert it and 1 liter over the molarity. So let's take a look at some quick, easy volume to volume problems. And we have this reaction, the iron 3 chloride and potassium sulfate are combining in this double replacement reaction. And I want to know what volume of 0.248 molar iron 3 chloride is needed to fully react with 38.9 milliliters of the 0.435 molar potassium sulfate. Now again, since this is a conversion factor, let's start with our volume. Now the volume, first thing we need to do with volume, of course, is we need to convert the volume into liters. So 38.9 milliliters and 1 liter divided by 1,000 milliliters gives us 0.0389 before John catches me on this one. 0.0389 liters. So now that's going to be of the potassium sulfate solution. So what I'm going to do is take that 0.0389 milliliters, the K2SO4. I'm going to multiply it by its molarity, which is 0.435, but I'm going to split the molarity into its units, moles of the K2SO4 in 1 liter of the K2SO4. So the liters, I'm sorry, that wasn't milliliters, that was liters up here. And so the liters of the K2SO4 cancel out. At this point, we have just normal stoichiometry and the balanced equation. So we have 3 moles of the K2SO4 in the denominator and 2 moles of the FeCl3 in the numerator. Let's cancel out moles of K2SO4. And now we need to get to moles of the FeCl3, I'm sorry, the volume of the FeCl3, so I need to put moles in the denominator. Since I've got the molarity, and remember that's moles over liters, I can put 1 liter of the FeCl3 in the numerator and 0.248 moles of the FeCl3 in the denominator. And when I do all that work out, I get 0.0455 liters of the FeCl3 solution, which would be, if you multiply by 1,000, 45.5 milliliters. And so, again, relatively straightforward. We've done this before. But I want to show you a cool little trick that we can use. And a cool little trick is that instead of having to convert directly from milliliters to liters and then use that in the equation, what I'm going to allow you to do is take this part of the equation, and I'm going to allow you to use that as the start of the conversion. Now, remember, molarity is moles per liter, but it's also moles for a solution that you have 1,000 milliliters of, because 1 liter is equal to 1,000 milliliters. So what I can do is I can just start with that 38.9 milliliters, and I can multiply that by 0.455 435 moles of, and that's, I should put the K2SO4, moles of K2SO4 over 1,000 milliliters of K2SO4. This is a correct statement. It's not the definition of molarity, though. So you can't use this to calculate molarity. However, you can use it to convert between milliliters and moles. All right. At this point, we would then just keep going the same place where we would then go into our mole to mole ratio. And on the flip side, we would multiply by 1,000 milliliters of the FeCl3 over 0.248 moles of the FeCl3 solution. And because we're usually working in milliliters in the lab, this would end up working out. Let me show you how that's going to work in this mass to moles problem. So that was a volume to volume problem. I'm sorry, I said mass to moles, mass to volume problem. So now you're going to have to do a little bit of thinking. This is not much different from when we had to think about stoichiometry with gases. Remember, stoichiometry is just about getting to moles and getting from moles. So I now want to know in this problem, if I have 0.568 molar silver sulfate, and I'm going to react it with excess copper, how much of that silver sulfate solution would I need to precipitate? 12.5 grams of silver. All right, so I'm going from the silver sulfate to the silver. So let's start off that the milliliters of the silver sulfate solution is going to start with 12.5 grams of silver. And we're going to convert using molar mass, 1 mole of silver, and 107.9 grams of silver. So the mass of the silver cancels out. Mole to mole ratio, now I have 1 mole of my silver sulfate over 2 moles of the silver. Moles of the silver cancel out. And now I want the milliliters. I want the volume. So now I can use that internal conversion factor, 1,000 milliliters over 0.568 moles. Put moles here, not molar. Those are both Ag2SO4, Ag2SO4. Cancel out the moles of silver sulfate. We've got volume in our answer, and this comes out to be 102 milliliters. If you had done it the other way, that would have been fine. You would have gotten 0.102 liters, which you would then convert to milliliters. And we are all done. Please go and do the homework, and I hope you're doing well. And we'll see you tomorrow for the lab and the pre-lab. Have a good day.